Howdy friends, hope everybody's doing well. This is part 3 today that we're going to do on graphing quadratic functions, that final part that we haven't gotten to yet. I hope everybody's doing okay out there. We're going into, about a week now in the new semester, but at least, a month almost into the quarantine. So I hope you're all staying safe, taking a look at your math, and thinking about reaching out to me if you have any questions. So without further ado, why don't we go ahead and get started on example 4 from chapter 4, lesson 1, and get this wrapped up so you can do the whole lesson. So if you're with me, if you're following along with me, I am at the top of page, let me pull it up real quick. Pull up your lesson at the top of page 223 at Real World Example 4. Real World Example 4. And if you look at it, it says, it's talking about charity. And it says, refer to the beginning of the lesson. So let's flip back to the very beginning of the lesson. So I'm just scrolling up my screen back to the very beginning. And if you go back to the very first page of chapter 4, section 1, or lesson 1, underneath where it says why, it says, and I'm going to read it with you. It says, Eddie is organizing a charity tournament. He plans to charge a $20 entry fee for each of the 80 players participating. He recently decided to raise the entry fee by $5, and 5 fewer players entered the tournament after the increase. He used this information to determine how many fee increases will maximize the money raised. So what's happening in this case is, just to try to simplify what it's saying, Eddie is having this basketball tournament, right? And as we know in the real world, anytime you increase the price of something, some people are not going to pay for that, right? Think about it like a game system, right? Everybody likes PlayStation, Xbox, Nintendo Switch, things like that. If you keep increasing the price of those game systems, eventually less and less people are going to buy those game systems, right? So in the case of Eddie, on the front of your page, he wants to know how much can he increase the price of this entry fee to this tournament and not exclude too many people. So he's trying to make the most money he possibly can given the situation, right? So we can build, if you go back to page 223, top of page 223 on example 4, we can build an equation. If I can find it. Oh, lovely. My page just crapped out. Let's try this again. It just decided to crash on me. Adobe did. So let me bring this back up. Oh, where are you at? There you are. Come on. There we go. Sorry about that, friends. All right. So once again, here's the equation we can set up. And let me break down each part of it. All right. So here's our $20 entry fee, right? That's my entry fee. Okay? Plus 5x. Well, when we add 5 here, that's an increase of $5. Okay? That's my increase of $5. Uh-oh. I'm losing my tray here. It's what happens when your kids start playing with your board. It starts falling apart. Okay. So we have a $20 entry fee here. If we increase it $5, X is the amount of times we increase it, right? So our variable, because we don't know, the question is how many times should Eddie increase the entry fee in order to make the most money he can for his charity, right? So X here is number of increases. That's our unknown in this case. We don't know how many times he's going to increase the fee for this entry. All right, but in this, each one is an increase of $5. Okay, over here, 80 is how many people. That's the number of people attending. Okay, and then over here it says minus 5x or minus 5. This minus 5 means 5 fewer. If he increases the entry fee by $5, 5 fewer people are going to show up. Okay, so 5 fewer attending. And once again, your variable's over here. Every time he increases, x is the number of increases. So if he increases it one time, 5 fewer will be attending. So that's the same thing over here. So I guess I can put that arrow down here as well. I know I got a lot of arrows flying around here, but I'm just trying to explain each piece of my equation up here. So $20 per entry plus a $5 increase times however many times he decides to increase it. That's one half of this. And then over here, the number of people minus 5 people for every time he increases the fee. So, you know, common sense tells us if we're trying to figure out how much money he's going to raise, you're going to take the amount of money per entry fee times the amount of people that show up. You're going to get your total amount you've raised. So that's why this looks so complex. We literally have smaller problems within a bigger problem. All right. So if we want to try to figure out what our formula is or what our equation is going to look like, we're going to multiply both of these expressions together, and it's going to give us a quadratic equation. In this case, we're going to do something that you may remember from Algebra I. When we have two binomials here, is what we have in this case. 2 terms times 2 terms. We use the FOIL method, right? If you don't remember this, I'll remind you of it. FOIL means first, outside, or outer, inside, and last. First, outside, inside, last. Which what it means is we take the first 2 terms, multiply them together, the outside 2 terms, the inside 2 terms, and the last 2 terms, and we multiply them together. And when we do that, we're going to get a quadratic equation. Let's go ahead and do it. I'm going to go ahead and erase these just different notes here. I'm assuming you went ahead and copied them down. So that'll clear up a little bit of space up here so I can write it all out. Don't let this freak you out. It's really not as challenging as you think. The hardest part here is taking the situation and translating it into an expression, which what I've done here in green. That's the hardest part. Once we multiply this out, we're just going to find the maximum, which is what we did in the previous example from the previous video I did, part 2. We're going to find the maximum, or the highest point, or the lowest point. In this case, highest point, because we want to find maximum. So first, 20 times 80 is going to give us 1600. Outside, my outside 2 terms, which is 20 and negative 5x. 20 times negative 5x is negative 100x. Inside 2 terms, 5x times 80 will give us, 400? So plus 400x. And then my last 2 terms, 5x times negative 5x will be negative 25x squared. Okay? At this point, once we FOILed everything, we multiplied everything out, what you want to do is you want to combine any like terms that you can. We also want to take your x squared term. It should always go in the front. So we're going to not only going to combine like terms, we're going to reorder the problem so it's in proper form, right? And remember, proper form, if you can see this up here, My standard form, once again, was f of x equals ax squared plus bx plus c. I showed you that in the previous couple of videos. So, and I think you can see that up there. Yeah, you can see it up there. So let's go ahead and clean this up just a little bit. So first, the negative 25x squared is going to be the leading term. Negative 100x plus 400x is going to give us positive 300x. And then we have plus 1600. And so there we have it. This is actually my quadratic function. Ax squared plus bx plus c. From this point, all I'm going to be doing is what I did in the previous example. I need to find my axis of symmetry and my vertex. I'm going to have my maximum there. It's going to tell me how much should Eddie be charging, or how many increases should Eddie make to the fee before he stops to make the most money he can in this situation. And a lot of us would like to know that, actually. If we're going to go and do some kind of charity outreach or something, you want to know how much money you can possibly raise for your charity before you start turning people away and losing money. Okay? So, in this case, A, remember I said in the previous videos you want to identify A, B, and C because we're going to be plugging them in. A is going to be negative 25 in this case. B is going to be 300, and C is going to be 1600. First thing we need to find is my axis of symmetry. So your A of S. Remember I said you can just abbreviate it. That's fine. My formula is x equals negative b over 2 times A. If b is 300, in this case, then negative b will be negative 300 over 2 times A, which in this case is negative 25. That's going to give us negative 300 over negative 50. And negative 300 divided by negative 50, if you want to do it easily in your head, the negatives will cancel out. These zeros cancel out, and 30 divided by 5 is just 6. All right? So there's my axis of symmetry. I can take this and plug it back into my formula. Oh, shoot, the phone's ringing. Oh, well, we'll get back to that. Not this formula, I'm sorry, this formula right here. I'm going to take 6, plug it back into my function here. That will give me my maximum. All right? So watch this. That'll be my vertex. And so what is, well, let's say P of 6. P of 6 in this case would be negative 25 times 6 squared plus, wake up computer, plus 300 times 6 plus 1600. Let's do some simplifying. I'm going to actually bring up my calculator for this one just because I'm good, I'm not that good. So we know 6 squared is 36. 36 times negative 25 is going to give us negative 900. So we have negative 900. 300 times 6 is 1800. And another 1600. And so negative 900 plus 1800 is 900, and 900 plus 1600 is 2500. Okay, so that is going to be our vertex. So let's translate that into some words. I'll write that up here. I'm going to go ahead and erase this, just so we can write into words what we're talking about. So what does this all mean? it means, in this case, your maximum, there's a maximum at 6, and that gives us 2,500. So if we wanted to translate that into words, into a couple of sentences, we can say Eddie would want to increase, oops, that's not how you spell increase, increase the fee 6 times. That's what this 6 means right here. Would want to increase the fee 6 times to make a maximum of $2,500 for his charity. Okay? So if you were, I don't know, if you were working for a nonprofit, let's say Eddie's your boss or your director, he comes to you and said, look, we need to make as much money for our nonprofit as we possibly can because we've got some people to reach out to. You would crank this out and say, hey, boss, we should increase it 6 times. So if we're talking $5 per increase 6 times, instead of charging $20 an entry fee, you actually probably should do $50 an entry fee, right? That's an increase of $30. 6 increases, $5 an increase. We're talking $30 on top of the 20 that's already there. $50 is what they should be charging for this entry fee. It might sound like a lot. They're going to lose some people, but they're going to make the most money in this situation. So that's what you do in this case. Let's change it up a little bit, because if you look at the bottom of the page we're looking at, let's see, we're doing good. I want you to look at the very bottom of page 223, where it says guided practice number 4. It's the same situation. We're just changing it just a little bit, okay? So look down there at the bottom of page 223. Same idea, and we'll go through it a little bit quicker than I just did. But it's the same scenario, same tournament. We're changing the amount of people and how things change every time you increase or decrease, right? So let's read this. And I'll show you the setup. So once again, our function is going to be p of x equals, and you've got 2 things. The amount of people showing up times the amount of money you're going to raise. Okay, let's read it. It says, suppose a different tournament that Eddie organizes has 120 players, and the entry fee is $40. Each time he increases the fee by $5, he loses 10 players. Determine what the entry fee should be to maximize the value of the pool. So once again, he starts with 120 players. That's going to go there. Every time he increases it, he loses 10 players. So he's going to lose 10 players per increase. Starting with 120, losing 10 players every time there's an increase in a fee. Times, so this is the amount of players showing up, times how much is being charged. And it says they start with a $40 fee, and every time it increases $5, that's when you lose the 10 players, okay? So amount of players attending times the amount of money you're charging. Once again, X represents how many times are you increasing that fee. We're going to do the same thing. FOIL, first, outside, inside, last. So let's do that. Take my 2 binomials, multiply them together. 120 times 40, that'll be 4,800, I believe. So we're looking at 4,800. Outside, we have 120 times 5. What is that, 600? Yeah. So 120 times 5x is going to give us 600 x. Inside, you're going to take 10 times 40, so negative 10. That'll give us what? Negative 400? Yeah. So minus 400x. And then last, you have negative 10x times 5x is going to give us negative 50x squared. So there we have it all multiplied out. Just like the previous problem. Combine any like terms we can. Put our x squared term out front so it's in standard form. So we're going to have negative 50x squared. 600x minus 400x is going to be a positive 200x. Plus 4,800. Once again, we're going to, at this point, find our axis of symmetry and our vertex, and that'll tell us where should Eddie be. So, my axis of symmetry, A of S. A in this case is going to be negative 50. B is 200. Once again, we really don't need to worry about C in this case. We won't care about C until we get to the quadratic formula, but it's good practice anyway. X is negative B over 2A. B in this case is 200, so negative B will be negative 200. 2 times A, or 2 times negative 50. 2 times negative 50 is negative 100, so we have negative 200 divided by negative 100, which will give us 2. Then we just take this 2, plug it back into our function. So my vertex will be P of 2 equals negative 50 times 2 squared plus 200 times 2 plus 4,800. Let's go ahead and simplify that. 2 squared is 4. 4 times negative 50 is negative 200. 200 times 2 is 400. And you got 4,800. Negative 200 plus 400 is positive 200. 200 plus 4,800 is 5,000. Okay. So what does this tell us? Well, in this situation, Eddie, so let's say, let me get rid of the first part up here so I can actually write out a sentence. Because we've got what we need to know now. Just a friendly reminder too, at any point, if you're working on this stuff and you're watching my videos along with it, pause it. Pause it at points where you need to just take a breather or get a little extra help. That's fine. But what does that mean? It means in this case you're going to have a maximum at 2, 5,000. Or in English, Eddie would increase the fee 2 times to get a maximum of $5,000. All right. So, I mean, this is just a very specific situation where you would know something like this, but you never know when that would probably come up in life. So it's kind of good to know. It's just another good example of where quadratics can actually serve us some purpose and help us out in everyday life and everyday calculations. So that's everything, friends. That's the entire lesson, all 4 examples. I realize this has been a long one. It's almost taken me, hour and a half, almost 2 hours of worth of video to explain this one. This is one of the longer ones we're going to cover. You're going to find that some of the other sections later on down the line in this chapter won't take as much time as this one. So just to remind you, the lesson that goes along with this, let me pull it up in Google Classroom. It is, make sure under Google Classroom you're going to Mr. Rudy's Algebra II, and it is the very first lesson. I'm actually uploading it on the day it's due. Don't freak out about that. Just make sure you're working on it. I want you to complete all odd problems, numbers 13 to 33 on pages 224 and 225. 13 to 33, so that's what I think about 10, 12 problems. Make sure you're reaching out to me for help. I don't mind talking with you through either Messenger or a video chat or email and explaining to you these problems one-on-one. But you got to take the initiative and get a hold of me, okay? So I think, yeah, problems 13 to 33 odd on pages 224 and 225. Look, friends, I hope you're taking care of yourselves. Ask me for help if you need it. I'm here. I'm ready. I'm willing. And I'll talk to you real soon, okay? Have a great day, everybody. Take care.